At the very outset, I am thankful to the organizers of Mechanical Engineering Department, Techno College of Engineering, Agartala for conducting uh, this 5 days faculty development program on Industry 4. And I am thankful also for inviting me as a resource person of this program. Now, in my lecture, I will try to cover actually Industry 4. It is a multidisciplinary area and integrated approach of many engineering disciplines. So today is the last day, as Panna mentioned. Today is the last day of 5 days program. So I think I have to give less effort to you because during the 4 days you at least you have acquainted with industry 4. But since it is a multidisciplinary subject, okay, not only mechanical engineering, production engineering, it includes electronics, instrumentation, and so many things, computer science. So it is very difficult for a particular lecture to cover all the things. What is industry 4? How many industries adopted industry 4? How it can be adopted? What are the challenges? What are the opportunities? What are the skill requirement of the workers or staff, employees? Okay, all these things are included here. And not only this, you have to make clear on industry also, the basic manufacturing. Without knowing the basic manufacturing processes, production system, okay, it is unwise to go for industry 4. So you have to make it clear the basic manufacturing processes. Otherwise, how you will implement industry 4 tools and techniques? Okay. So in the beginning, industry 4, it also industry 4 means the fourth industrial revolution. Fourth industrial revolution is the next phase in the digitization of manufacturing sector. Okay, so industry 4 means the fourth industrial revolution. So of course, before that, three industrial revolution were there. Okay, so what are these for three industrial revolution? And in this figure, industry 4 includes so many things. Okay, internet of things, additive manufacturing, simulation, augmented reality, system integration, robotics, data analytics, and so many things. Okay, so at the very outset, you have to make it clear the manufacturing processes. Okay, the industry, manufacturing industries related to manufacturing, then try to implement all these techniques. Now, coining of the terms. Okay, when and where the term, okay, first coin. You have to know the history also. German government officials would be the first to launch Industry 4 at 2011. Okay, in one conference. Okay, around 90% of all manufacturing techniques now have any sort of IT assistance. Okay, IT assistance. Without the assistance of information technology, it is very difficult to proceed for industry 4. So coining of the terms, okay, you should remember the German government is the first, okay, official. They coined the terms uh, Industry 4 or Fourth Industrial Revolution. Now see the industrial evolution, that is the uh, gradual change of the industries. Okay. First industry 1.0. Industry 1.0, it happened due to mechanization. That is at that time uh, steam engine. Okay, steam engine was introduced. Okay, then weaving, loom, etc. In industry 2, mass production, assembly line, and electrical energy. During industry 2 evolution, electrical energy came, and due to this, this has come. Mass production. What is mass production? Any idea? And assembly line. Okay, I will share. Okay. And similarly for industry 3, automation, computers and electronics. And now we are here in industry 4, cyber physical systems, internet of things and network. I think, I do not know the previous lectures explain this thing or not, the cyber physical system, internet of things, okay, networking. So this is the industrial evolution, that is gradual change of the industry. Now you see when it happened, the same picture, but it shows the year or duration, not any particular year, because some transition period is always there. Say around mechanization started 1784, similarly 1870. So around 100 years, approx 100 years, okay, industry 1.0 was there. Then 1970s approx, and today is the industry 4. This is evaluation of evolution for industry 4. Okay, evaluation of industry 4. That is, we are evaluating the evolution of industry 4. The first industrial 1760 to 1870. In another source it is written the exact duration. Exact duration may be slightly different. So at that time steam engine came, okay, and during this duration, say, the second industrial revolution also lasted for approx 100 years, 1870 to 1970. And that time I told electricity generated, and due to the generation of electricity, all these things has come, mass production, assembly line. Similarly, for the third industrial revolution, PLC enabled manufacturing processes, robotic manufacturing, and CNC. Okay, CNC, NC, CNC, DNC, that is numeric control machine tools has come. So all these things came, including robotics, in the third industrial revolution. And fourth industrial revolution, 20, fourth industrial revolution means 2011. 2011. So here IoT in manufacturing, supply chain, data analytics, okay, all these things came. Smart manufacturing, smart factories, all these are the key words, burning issues nowadays. Okay, we are writing the technical article. Okay, so you know better. Okay, so many recent papers, articles are coming out on these topics: smart manufacturing, green manufacturing, smart factory. Okay, data analytics, data science, all these are the key areas. And these are included in the fourth industrial revolution. So, in a very nutshell, single word, first industrial revolution caused by mechanization. Okay, first industrial revolution caused by mechanization. Second industrial revolution, what is the what was the cause for second industrial revolution? Electrical energy, electrification. Similarly, for the third industrial revolution, electronics and automation, and for the fourth industrial revolution, digitization and robotics. And all these are the driving technologies for industry 4. Internet of things, cloud computing, artificial intelligence and machine learning, edge computing, cyber security, digital twin. Now come to the manufacturing processes. Okay, what are the different production methods? Okay, those who have mechanical or manufacturing background, you know, job production, batch production, flow production, mass production, cellular production. Just now I have mentioned about the mass production. Okay, so mass production is a method of manufacturing method, production method. Okay, and other processes are this. Now this is okay, but what is mass production? What is mass production? Your final year student, any idea? Any idea? Hmm. And batch production? Batch in batch production, actually products are produced in a batch of certain quantity. Okay, so try to remember these different production methods and types of manufacturing. Types of manufacturing. How many ways you can classify the manufacturing processes? Okay, based on continuous or discrete. Okay, continuous production method. Continuous production method. Think about the chemical industry. Chemical industry. Okay, or any process industries. Continuous and discrete production means intermittent. Intermittent production. Variety and volume. Variety and volume. How in your manufacturing concern you are producing the products. Okay, now this is related to variety and volume. Volume should be high or variety should be high. Okay, as per the customer order. Third, raw material to final product. Raw material to final product. You are receiving the raw material from the outside vendor, okay, supplier, and finally through the different uh, production processes, ultimately you are getting the final product and it is going to the end user in the market. Okay, now based on this you can classify the manufacturing process. How many manufacturing processes are involved here? Okay, only 2, 3 or 15? Okay, only conventional manufacturing processes are involved here, or NC, CNC, some non-traditional manufacturing processes are involved here. Robotics is involved here or not. So based on this, you can classify the manufacturing processes. To order or to stock. To order or to stock means you are producing the product, you are making your inventory. Okay. Similarly, raw material is also going to the inventory and it is going to the end users. Okay. Now you calculate how many stock you should make for making the products. Similarly for the final products also. That is to order or to stock. Size. Okay. Size, that is quantity of the as well as size, that is size of the products, final product. Then machinery used. Okay, I have already explained machinery used. Only conventional machineries are used for the production method, or non-conventional machining are used, non-traditional machining. Okay, all these things. So based on this criteria, you can classify the different manufacturing processes. So continuous flow or process type. Okay, continuous flow operations, the chemical and the for mining industries. Okay, mainly. Okay, for chemical and mining industries and oil refineries. Okay, and which produce large amounts of bulk material. The products in these groups are usually measured in units of volume or weight. Batch size is large and product variety is low because it is continuous type na. Oil refineries, mining products, chemical product, of course product variety is low. So these are the nature or characteristics of continuous flow or process type. Now discrete parts manufacturing, this is the first one, continuous or discrete. Discrete parts manufacturing denotes operations involving products that can be counted. That is intermittent type. What distinguishes manufacturing from process industries is the potential flexibility of its output. Okay. A special feature of discrete manufacturing is that the end product, generally made of several components, can be disassembled or reassembled, which cannot be done for the continuous type. Okay, but here for the discrete parts manufacturing, it can be done. Now come to the second one, variety and volume. Okay. Another way to look at manufacturing facilities is according to variety and volume. A low variety, high volume operation is easier to manage. Say, mind it. A low variety, variation is less, but volume is high. Of course, it is easier to manage considering the production processes. Since dedicated automation is possible, a high variety, low volume operation on the other hand is difficult to operate. Are you getting? High variety and low volume. Based on volume and variety, discrete manufacturing is of three types. Okay, the first one, continuous or discrete. This discrete manufacturing is of three kinds based on variety and volume. Mass production, batch production, job production. From this source, the term mass production has come. Okay, try to find the source. Okay, so mass production, batch production, job production. Now you can interpret this, okay, for your better understanding in a plot. It is job production, one mistake happened. Okay, the last one. Okay. Job. So you say this x-axis is variety and this is volume. Okay, variety is low, variety high, volume low, high. So in case of mass production, this one variety is low but volume is high. Variety is low, volume is high. And in batch production, variety is comparatively higher and volume is lower. Okay, so this is mass production, batch production and job production in variety versus volume length. The same thing we can represent in this way: mass production, batch production, here job shop, and flow production. This is also variety versus volume, and here it is shown that this is continuous production system and this is intermittent production system. Okay, means these are belongs to continuous production system, and this is belongs to the intermittent production system. We always use the term project. Okay, project. So in case of project, okay, in case of project, there is no question of variation of volume. Okay, variety is high, volume. Because project always you consider the single project. Nah, in college, Techno College of Engineering, one project. College has been upgraded to university status. Okay, so this is only one project. Okay, the authority will not think about the other college upgradation. Okay, so project always in this way all the manufacturing process can be represented. And this is already explained in mass production of discrete parts, for example. Okay, this is an example. Batch production already explained. Job shop production explained. Now, why I have told all these things? Okay, I have I am here for delivering lecture on industry 4. Why I have told this? Because you have to know the basic production system, basic manufacturing system. Without knowing the manufacturing industry, what is industry? What particular job is done in the industry? How you will implement industry 4? Now, in the era of industry 4, what happened? A paradigm shift from mass production to mass customization. Okay, mass production to mass customization. Okay, in the era of industry 4. What does it mean? What does it mean? Because so many days in your company or manufacturing concern, okay, mass production means bulk quantity, variety is low. Bulk quantity, variety is low. Here, some mass customization means you are focusing on the customer every time. Customer is the first priority for your product. You have to collect their feedback. In case of mass production earlier, when it happened in the second industrial revolution, okay, without taking the customer feedback for the product quality, reliability, characteristics, function, so on. But under industry 4, you have to collect the customer feedback for the manufactured products quality, reliability, and so on. Okay, and so on. That is a closed loop system. Earlier it was open loop system. You are producing the product, considering the mass production, it is going to the outside market. Okay, you are least bother for the customer satisfaction, and customer also had no option. But nowadays business is very much competitive in nature. Okay, so many manufacturing concern parallel with you has come in the market. So you have to change your strategy. Okay, that is from the open loop to closed loop you have to come. Closed loop means you are collecting the customer feedback, okay, for the lifespan of the product, quality, reliability, and so on. And accordingly, you have to change, modify, implement in all stages of production system. That is your focus 100% on the customer. That is the mass customization. This has happened in industry 4. You read this thing, what are the characteristics, what are the characteristics for mass production, and now what are the characteristics for mass customization. See, Okay. So you have to look into the matters of customer feedback, customer satisfaction, okay, for everything. Customer focused or oriented manufacturing process. And this is good to know the TPS. TPS means Toyota Production System. Okay, Toyota Production System. It is actually benchmark system. The mechanical engineer, you know the term benchmark. Okay, benchmark. So TPS. Why TPS is an example for all the manufacturing processes? Because it is the benchmark manufacturing processes in terms of quality, reliability. So many things are here. Okay, if you can implement these system, quality related system to your manufacturing concern, it is good. Suppose just in time is a philosophy, okay, manufacturing philosophy. Okay. Then Jiduka, all these things, this is all these things are related in the quality engineering. Okay, so you should know for your manufacturing concern all these things. Toyota production system, where it was implemented, where you should know this. Toyota, Toyota production system. Ah, yes, good. Then you have to consider the lean concept also. What is lean? Lean manufacturing. Okay, very famous terms. Lean manufacturing. What is lean? Lean concept for industry 4. Okay, lean concept of industry 4. Lean manufacturing mainly focuses on elimination of waste. Elimination of waste. Okay, waste means not only garbage. Okay, waste means not only garbage. See, here it is explained nicely. 8 wasted of lean manufacturing. Maybe it is 10, 6, okay, hardly matters. But here some examples are given. Okay, unnecessary transportation. Unnecessary transportation. All these are self-explanatory. Overproduction. Then unnecessary motion. Unnecessary motion means unnecessary motion of the staff, employees, okay, with the raw materials or aimlessly, okay. Then excess inventory. You have idea on inventory, okay, excess inventory. Then waiting or idle time, over processing, defects, unutilized talent, okay. Elimination of waste. Waste means not only the garbage, okay. These are the waste considering the manufacturing concept. Okay. Unutilized talent. Unutilized talent means industry has different department section, okay. Somebody is deployed there, somebody is, okay, okay. But everybody has some limitation at the same time, okay. Everybody has some the strength also, okay, technologically or socially or economically, okay. So as a competent authority, you have to identify their talent, on which department or for which section this particular staff or worker or employee should be deployed, okay. If you cannot judge them, okay, I'm not telling that they have no capacity. Everybody has capacity in different direction. So as a competent authority, you have to judge, you have to evaluate this thing, accordingly you have to deploy them there. Somebody is technologically very talented, skilled, somebody for other other work for the industries, okay, that is unutilized talent. Okay, in industry 4 concept, nowhere it is written that if somebody has no talent, okay, let them go out. No, never. Okay, I have searched, I have read so many articles. Nowhere it is written for unutilized talent or those who have less skill, okay, let them go outside. No, they are telling that give them training, upgrade them technologically, or first identify them for which area they are competent. Accordingly, you do this thing. Okay. Unutilized talent, it does not mean that throw them from the industry. No. And these are the areas for lean 4 also. Okay. Lean 4 means lean manufacturing concept for the industry 4. Okay. Because nowadays I have seen in the articles, in most of the cases they are okay writing, they are claiming that is education system for the education 4.0, that is the education system training which is required for industry 4, they are telling that this is education 4.0. Okay, suppose you are first time reading education 4.0, it is very difficult. What is industry 4.0? It is actually the education or training or skill which is required to upgrade the employees. This is in education 4.0. Okay, that is normal education, traditional education to education 4. I am citing more examples of 4.0. Okay, and these are the areas of the lean 4. Lean 4 means for lean manufacturing. What are these? Blockchain and cloud, then artificial intelligence, then augmented reality and virtual reality, smart sensors, internet of things, additive manufacturing. Now I am telling for a particular person, okay, or suppose you are mechanical engineer, it is very difficult to grasp or to upgrade your knowledge for all the areas at a time. Okay, suppose Shishendo, he knows additive manufacturing. Okay, he is doing work on one example of additive manufacturing is 3D printing. Okay, 3D printer and 3D printing. Okay, additive layer by layer. Similarly, blockchain. Okay, Motoshi knows. Okay, blockchain technology. Okay, then artificial intelligence and machine learning. Okay, so that's why initially I have told it is an integrated approach. It is an integrated approach. You have manufacturing concern, you want to upgrade the manufacturing organization to industry 4, okay, then you have to consider these areas. So that's why it is multidisciplinary in nature and integrated approach. Now, supply chain management, it is also related to industry 4. Supply chain management, it is very much important, and it has come into the literature in the era of industry 4. Okay, and sometimes they are telling that supply chain 4.0. Okay, means supplier selection, supplier characteristic, supplier selection for your manufacturing concern, considering the industry 4 technology. If I tell supplier supply chain SCM 4.0, what does it mean? Supply chain management 4.0, what does it mean? Means supplier has to knowledge also on industry 4. You have the knowledge, at the same time your supplier or vendors, those who are supplying the raw materials for industry, they have the knowledge, not only knowledge, they have to implement industry 4 things, internet of things, networking, smart sensor, actuator, all these things. So education for them also. Okay, I am not telling supply chain management. This is a vast area. I am telling supply chain management 4.0. That is, your vendor or supplier has the adequate knowledge also for your benefit, at the same time for their benefit also. We generally select supplier. Okay, for a particular raw material, suppose there are 4 5 alternatives. Okay, supplier 1, supplier 2, supplier 5. Okay, to which supplier you should go, for which supplier you should give the order for supplying the raw materials to your industry. This may be one criteria. Adequate knowledge on industry 4. Okay, so one benefit you are getting, you can implement the industry 4 for your industry. At the same time, benefit for them also, because they will get the order in future, not only to you, for other factories also. Okay, so this is, and process view of a supply chain. Okay, mainly there are two views, one is cycle view and one is push pull view. Okay, push pull view means, push pull view, this is also important. What do you mean by push push system, pull system? The push pull view of a supply chain under the industry 4 concept, you should know this. Okay, push system means, put system means, say, very much interesting. You are producing the products. Okay. Okay. You are producing the products without knowing the market demand, customer demand. Okay. Implementing the forecasting techniques. Okay. You are producing the products, and the finished products, they are accumulating in your store, that is inventory. Now this is a burden to you. So what you are doing, you have the tendency to push the products into the market. You naturally, you have the tendency to push these products into the market. This is the push type. And pull type means, why I am telling all this for industry 4. Pull type means you are least bothered for the market, because you are maintaining the quality, product reliability, product surface finish, product lifespan, everything. Automatically, customer will come to you. That is, you are pulling the market, you are pulling the customer. Okay, and in the pull system, you should not accumulate the finished products in the inventory. Okay, you will produce the products based on the actual demand of the market. This is the basic difference between push system and pull system. In push system, you do not know the exact demand, irrespective of the demand of the market. Okay, you are manufacturing the products, and automatically you are trying to push the products into the market. That is the push. And pull means you have the ability to attract the market to you due to maintaining of all quality related characteristics. This is the pull system. Push pull boundary of supply chain for industry 4. Now under the industry 4, this is actually related to optimization technique. How much quantity you should produce, how much quantity you should produce. Okay, so that you should not incur loss for your manufacturing organization. That is determination of the push pull boundary. This is a big problem of optimization. Optimization is related here. So in industry 4 concept, what they are doing, that optimization, just now I have mentioned that is to find out the push-pull boundary. Okay. Other than the traditional optimization techniques, operations research techniques, nowadays data science has come, data science, cognitive computing, deep learning, all these tools and techniques you can apply. Then layout, I am telling all these things very briefly. Layout, what is layout? What is layout? Layout means facility layout, facility layout. Okay. Layout means the arrangement of the departments within the facility and also the arrangement of economic activity centers within each department. Okay. Suppose Techno India University. Okay. It is sanctioned, Techno India University. Building construction is going on. Okay. So they are considering all these techniques. Okay. The building which is going on for Techno India University, okay, where Vice Chancellor room is there, okay, principal room is there, staff room, lecture hall, all these things. Similarly, for manufacturing organization also. Okay, what is the objective? Why I should go for layout? This is very much related in our engineering and manufacturing. So that unnecessary motion, unnecessary movement with the raw materials, unnecessary movement with the finished products, okay, then motion during the maintenance, okay, should be less, okay, and for future expansion also. Today, only one building is sufficient. After 10 years, you do not know, this type of 5 buildings may come. Okay, so this provision should be there. Okay, for future expansion or contraction both. This is the importance of facility layout and objectives of good layout. Okay, that is I have told, reduce machine interference. Okay, two machines are there, workers are working. Okay, so minimum gap should be there. Okay, for workers movement, for trolley movement. Okay, so reduce machine interference, identify and reduce bottlenecks, provide ease of supervision. You are supervisor. Okay, 3 times in a day you will visit. Okay, so that for your easy and comfort movement. So all these are the now types of layout: product layout, process layout, fixed position layout, hybrid layout. Mainly 4 types. Okay, product layout, process layout, fixed position layout, hybrid layout. Initially, I have mentioned the assembly line. So the concept of assembly line will come here. Okay, product layout and process layout. Please listen all this. Okay, you are second year now. The third year and final year, all these things will come. So product product layout, you see this diagram, product layout. So from the product layout, this assembly line concept will come. What is assembly line? For mechanical engineer, those who will do work in the factory, okay, or higher study, whatever it is, this is very much important. Assembly line. Assembly line is related with product layout. Okay. See, one con please listen. One conveyor belt is there, one conveyor belt is there, and some workstations are there. Okay. Okay. Consider automobile. So workstation 1, workstation 2, workstation 3. Workstation 1 has some particular job. Similarly for 2 and 3. Workers are there. In workstation, one worker is there. 2, one worker is there, 3 worker. His job is only fixed. Suppose the headlight. Okay. car 1. So car body has come through the conveyor belt. So when it will come, he is fixing the headlight. Then it will go there, and his job is rack containing tail light sub assembly rear. Okay, tail light. In the workstation 2, the second worker, he is fixing the tail light, and this will go there. He is doing this steering wheel. When the car will come from workstation 1 to workstation 2, then another car will come. Then another car will come here, and the first workman is doing this particular job. Okay, after finishing, this car will go there and this car will go there. So here the third workman is doing the steering wheel fixation, and this car will go there. This. Finally, the mm, output or the finished product is coming out from the conveyor belt. So here conveyor belt input, conveyor belt output. Okay, and from the output you are getting the final product. It is going to the store, then it will go to the market. Okay, this line is called the assembly line, because the function of this line is to assemble. Car body has come in the 3 workstation or 8 workstation or 10 workstation. People are doing this job. Okay, they are assembling, and finally the final product is coming out. That's why its name is assembly line. Now, your job, your job is to design the assembly line. It is very much difficult, very much important and difficult. Okay, assembly line design. Why the question of assembly line design? Anybody? Yes, yes, excellent. Suppose he is taking 10 minutes, hmm? And he is taking 10 minutes. It's the second person, and he is taking 15 minutes. 5 minutes, 5 minutes higher. Okay, so when this car will go there, okay, then work has not been completed by the first worker, so this man will be idle. Okay, this man will be idle. So assembly line design is a tough job. Here 3 workstation. Practically in the industry, automobile industry, there are 15 workstation. In 15 workstation, 15 workmen is there. Okay, and the duration for completion of a particular job is not fixed. So you have to design in such a manner that the ideal time should be less. If the second workman sits for 5 minutes, okay, now you consider 8 hours per day in a shift, how many minutes, how many hours you will be idle. Not only this, at the same time, the first workman will not get any ideal time, whereas the second workman will be ideal. Okay, this will create an ego problem. I am not getting any time for my job, and he is getting, because assembly line design is not perfect. This is a simple example. Actually, it is very much complicated. So here, for the entire time is called the cycle time. So for the entire cycle time and for the whole assembly line, okay, you have to consider their skill, talent, time required for a particular job in a work station, all these things. This is explained what I have told. And process layout, I am not going this because it is not possible to cover. I have just explained the product layout just to give you the idea of assembly line, because assembly line is related with the product layout. Okay, product layout. Product layout means a product layout means in the conveyor belt a particular job is being done. Only automobile car finished product is coming out. Hour after hour, day after day, month after month. And the worker, their knowledge and skill is fixed for a particular workstation. So just to make you clear the assembly line, I have told the product layout. Process layout is different. I am not going for process layout. And this is done actually nowadays in computer as well. Some algorithms are there. Okay, craft, very famous algorithm, craft, then correlate, LDIP. Okay, actually in industry, the industrial engineer, okay, they do design of the assembly line using the modern software. And assembly line system in industry 4. So assembly line system in industry 4, nowadays they are telling assembly line 4.0. Assembly line 4.0 means assembly line design considering that your industry is being upgraded or likely to be upgraded to industry 4. So you have to come out from the traditional concept of assembly line design, okay, to the assembly line 4.0. Here, these things, the criteria are mentioned here. When you will go for assembly line 4.0 design, then Internet of Things that you know, I think it is explained by the previous speaker. Okay, Internet of Things very much integral part of IoT, is very much integral part of your industry 4. IoT and networking. Okay. Now IoT market share in, see, I am interested for manufacturing only. For manufacturing, okay, it is 40.2 approx. Okay. I collected from one source, it is 40% market share. And in other areas also IoT application is there. Then IoT enablers technology, big data, AI, artificial intelligence, cloud computing, sensor technology, deep technology. Sensor technology is very much integral part of IoT. Sensor technology, sensor and actuator. Okay. When you will go for industry 4 upgradation, you have to know the sensor and the actuators. See here, sensing, networking, actuation. Sensing means your sensor, your sensors are sensed the actual data. Suppose machining, you are doing the machining. Okay, so sensor are collecting the actual real life data. Then through the network system, it is going to the physical system, and the actuator will do his work. Okay, it's work. So what sensor do in the IoT system? And sensor detects change in the ambient conditions or in the state of another device or a system and forwards or processes this information in a certain manner. Then sensor classification, analog, digital, scalar, vector. Okay. Now what is actuation and what actuator will do? And you know the actuator type. Okay, hydraulic, pneumatic means air based, then electrical, thermal, mechanical. And this is important flow diagram of IoT networking. Okay, device, then local network to internet, then backend service means processor or server, then application. And IoT categories, one is IIoT and another CIoT, means consumer IoT and industrial Internet of Things. Okay, for your manufacturing, industrial Internet of Things, you should have knowledge. And future expectation of IoT, trillions of sensors, because sensor technology is the main of IoT system, and to implement industry 4 concept, billions of smart system, millions of applications. Now, what are challenges in implementing Industry 4? Okay, these are the basic concept. Okay, till now I have told you what are the technologies and what are the basics. Now, what are the challenges in implementing Industry 4? There are 15 challenges. Uh, I am just telling the headline. Explanation is here. Low management commitment and support. Self explanatory. Okay, low management commitment and support. Your management should be committed for this. Okay, and they should give support in all aspects. Low knowledge of industry 4 concept. Low knowledge of industry 4 concept. Suppose you have one manufacturing organization, okay, from top level management up to the bottom level management, all are there. Okay, nobody has knowledge on industry 4. Okay, so they only want to upgrade the industry 4. This is vague. Okay, security and data privacy issue. Data privacy issue is a big problem for this, because you see industry 4 networks are prone to cyber attack, posing significant challenges to data safeguard in the implementation of this model. Okay. So these data privacy issues should be overcome. Lack of IT facilities. Okay, information technology or other than IT facilities, how it is possible? Everywhere it is required. Industry 4 lacks global norms. Till now, till today, okay, Industry 4 concept in the developed countries already implemented, or they are implementing. Okay, developing countries like our country in India, okay, people are telling on Industry 4, Industry 4, okay, but there is no uniform norms. Industry 4 lacks global norms, standardization, need for enhanced skilled workforce, that you know better. Okay, need for enhanced skilled workforce. Okay, you can upgrade them, training is required. Seamless compatibility and integration issues between different technologies, IoT, sensor, actuator, okay, sensor, networking, then actuation. Okay, so everywhere seamless compatibility and integration is issues in different technologies. Poor research and development in industry 4 implementation. Okay, it is good that Techno College of Engineering Agartala, they are conducting industry 4 techniques, and we are getting the opportunity also to learn. Okay, to give this lecture, I have also read so many things, articles. Okay, so it is an opportunity. At the same time, you are also listening something from the 5 expert for 5 days duration. Okay, somebody you will know better than this. Okay, so this is the core research and development industry for industry also. Okay, they are least bother for R&D. In 95% industries, they have no R&D section. Only they are manufacturing the products, okay, and it is going to the market, profit, 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 profit. Okay, always no separate R&D section. Okay, so if they want to implement industry 4, they have to do the R&D problem. So many R&D issues are there. Legal issues of your industry. Okay, the barriers to industry 4 concept are because of the lack of guidelines and working methodology in emerging nations. High training and consulting cost. Okay, high training. Okay, I am every time I am telling hello. I am telling that staff training or workers training are required, but or you are giving the responsibility to an outside consultant. Outside consultant. Here, consultancy cost and training cost are high. So industry will always think regarding this high cost. Then lack of government support and policies. Okay, lack of government support and policies. Without the government support, it is very much difficult, because if government will arrange the workers training, staff training, upgrading knowledge through training, okay, skill requirement, then it will be easier for you. So that's why government support is required and policies also. Lack of capability in implementing new industry models regarding organizational and process changes. Then poor industries digital strategy, vision, operations. Okay, vision is required. Okay, industries vision and mission. Hmm. College, Techno India College vision and mission. So vision is required. Unclear economic benefit of industry 4. Unclear economic benefit, because company's boss is every time he is thinking why I should go for industry 4, what will be the economic benefit. It is unclear actually to them. Okay, high adoption expenditure. Okay, initially, okay, it cost, the degree of adoption expenditure for industry 4 innovations is very high. Okay, decreasing in its adoption, engaging quality, particularly for manufacturing industries situated in emerging nations. So these 15 are the challenges in implementing industry 4. And skill requirement of people in industry 4, already told you. Okay, human resource department should be active for this. Okay, what are the skill requirement of people? It is written here. Now, implementation phase, there are some phases. Okay, in overnight it is not possible. You cannot change, you cannot upgrade. Okay, industry 2 industry 4 or industry 3 to industry 4 overnight. Okay, some phases are there. Then digital twin, another important factor. Okay, virtual presentation, integration with IoT, key benefits. Okay, these are the components of digital twin. And finally, data analytics. Okay, data analytics for industry 4, because I have mentioned you 6 or 7 vital areas for industry 4. Okay, data analytics is one of them. Okay, so I am showing one case study of mine. Okay, I have done this case study to uh, achieve some sustainability. Okay, what is sustainability? What is sustainability? Sustainability has three components: economic aspects, environmental aspects, and societal aspects. Okay, sustainability, very much burning word, burning issues nowadays. Okay, very much burning issues nowadays. Sustainability, sustainable manufacturing. Okay, sustainable manufacturing. What do you mean by sustainable manufacturing? What do you mean? You know manufacturing? Hmm? Conventional manufacturing, sustainable manufacturing. What is sustainable manufacturing? sustainable, when we utter these terms sustainable manufacturing, okay, so we have to consider these three aspects: economic aspects, environmental aspects, societal aspects. Okay, suppose you have adopted one new manufacturing technique, okay, one new manufacturing technique, or change you change one conventional manufacturing process to other. Okay, now the question is how you will claim that this is sustainable. Is it, am I clear? Hmm? One particular manufacturing process. Okay, now you have you want to upgrade this manufacturing process, you have adopted another manufacturing process, okay, new manufacturing process, okay, for sustainable, for achieving the sustainability. How you will claim that this is sustainable? How you can measure the sustainability? How you can measure sustainability is a burning issue, no doubt about it. Next 10 years it will go sustainability, but how how you will measure the sustainability? First of all, sustainability cannot be measured by any contract or non-contract device. Okay, sustainability cannot be measured. That is direct way. By any contract or non-contract device, it cannot be measured. So you have to see, you have to observe, you have to calculate, okay, that how much economic aspects changed by your process, how much environmental aspect changed, how much societal aspect changed through your process. If it is greater than the traditional one or conventional one, then only you can claim, yes, my process, my manufacturing process, my new process which I adopted, it is more sustainable. Otherwise, not. Okay. Suppose only sometimes it is in the only economic aspects gain or environmental aspect, then okay, okay, you have achieved some component. Okay, am I clear? Okay, I want to tell you sustainable manufacturing. Okay, sustainable and this sustainability mainly three components. Okay, economic, environmental, society. Sustainability cannot be measured by any device. Okay, by any device. Now you have to analyze the economic aspects or environmental aspect or societal aspect or in any combination of these three. If it is greater, you can prove, then your process is more sustainable, not 100% sustainable, more sustainable than that of existing one. Okay, this is sustainability and analytics has been applied. Say, yeah, any analytics, data analytics has four components. Okay, say analytics is very much important. Like industry 4, analytics, everywhere analytics. Assembly line 4.0. Okay, this 4.0, education 4.0. Similarly, for data analytics also, everywhere. Supply chain analytics. Okay, energy analytics, machining analytics. So this is the basic concept. Okay, this is the basic concept, analytics. You can implement it anywhere. Mainly for, remember this, four component. What are these four component? Diagnostics, deterministics, predictive and prescriptive. Okay, any analytics has four components: diagnostics, deterministics, predictive, prescriptive. Earlier we used to think only three. Okay, prescriptive has come. Okay, implemented new. Prescriptive means like doctor's prescription, like doctor's prescription. Okay, means you are prescribing, means decision making is involved here. Okay, here not medical prescription, decision making. Okay, diagnostic for any manufacturing process. First diagnose. First diagnose. Diagnose means data collection. Data collection. This may be generated data or real life data. Machining. Okay, you are doing the machining. So lots of data will be generated. Okay, lots of data will be generated with variation of different process parameters. No doubt about it. Okay, or without the practical exposure, data can be generated from social media also. Nowadays, so from social media, so many data generated. And then first you diagnose the system, then determine the system based on those data, collected data. Based on those collected data, okay, then determine the system. Then predictive. Predictive means model development. Here, model development means here artificial neural network or other neural network. Okay, these things are involved. And deterministic you can do through any deterministic tool. And finally, prescriptive. Prescriptive means now your role is like a doctor. Okay, you will give the final suggestion. You are consultant to the manufacturer. Okay, that is the decision science is involved. Don't think that it is a small area, vast area. This is a vast area. Okay, so how many components in analytics? Four components: diagnostics, deterministics, predictive, prescriptive. Okay, yeah, in predictive, so many tools and techniques are here. Predictive, ANN, genetic algorithm, data envelope analysis. Okay, so many techniques. And prescriptive, so many decision making models are related. So I have done this and I have given this name. Diagnostics mean eyesight. Okay, you are seeing the data. And deterministic means inside. Predictive means inside. You are predicting for near future what will be the situation. And prescriptive means foresight. And data, this is my model. Okay, so data is there are 5 6 types of data can be classified. This is actually classification of the data: volume, variety, velocity, veracity. Okay, volume means use quantity of data is, that's why nowadays it is called big data. Why big data? Why big data? Because huge quantity of data is generated. It told you, with variation of the process parameters. Okay, for other computational area from the social media, etc. etc. Okay, variety. Variety means the data classification. Okay, you classify. Velocity. Velocity means at how faster the data is generated. Okay, and veracity. Veracity means what is the truthfulness of this data. Truthfulness, okay, of this data. Then deterministic, I already explained. Predictive, okay, in predictive data mining, data envelope analysis, and other numerical tools you can apply. and finally prescriptive. Prescriptive means decision making model generation. Then your work will be completed. Okay. Suppose you want to apply analytics in your field, then this will be a complete work. Okay. You have generated the data. Now you determine using the deterministic tool. Then go for prediction, go for prescription. Okay. This is the fundamentals of analytics. Thank you, and think for industry 5. Okay, because you have evaluated the evolution of industry. Okay, Evo evolution of industry. Okay, I have showed you. So from industry 1.0 to 2.0, 3.0, 4.0. So it is coming in near future industry 5.0. Okay, industry 4.0 is not completed at all. Even it is not implemented in 80% cases, huh? But still in near future 5.0. Okay, I have seen in one article, industry 5.0, they will focus, they will give strength on humanization, that is human centric. In industry 5, they will give more stress, they will be focused on human centric issues. I have read one article, I do not know, it has not come in industry 5. And what will be the action during the transition period? Suppose industry 4, okay, I already told, okay, implementation or adoption, it is not possible overnight. Okay, some transition period is there. So from industry 4 to industry 5, say human centric, humanization. What as a industrialist, as a industry people, as a manufacturing engineer, what will be your role? What will be your role? So you can think on this. That's why I have written think for industry 5. Think for industry 5 means it does not mean just we should work for industry 5. What will be our role during the transition period, and what will be the main parameters of industry 5? Okay. So during my lecture, what I have covered, the what is industry 4, that is fourth industrial revolution. When this happened, first industrial revolution up to fourth industrial revolution, and what is the main cause? Suppose first industrial revolution caused by mechanization, second industrial revolution for electrification, third industrial revolution for digitization, okay, and automation, and fourth one for, okay. Then what are the integral parts of industry 4? Sensor technology, internet of things, okay, then data analytics or big data analytics, additive manufacturing, 3D printing under additive manufacturing, okay, all these things. Then uh, I have explained some basic concept, okay, because without knowing the basic manufacturing processes, okay, so it is not good. You, because you cannot match, that's why the minimum materials, okay, I have shared with you different production methods, mass production, assembly line design. What is assembly line? Assembly line design. Then supply chain under the view of industry 4, all these things. Okay, then what are the challenges of implementing of industry 4? Skill requirement, then data analytics. This part, data analytics, I have explained more. Some other parts are required, so other speaker will share, because it is not possible to give to cover all the things in one lecture or to garner knowledge for a particular people in all the this because it is integrated approach. So many disciplines are here. Is it clear to you what I have shared? First try to make it clear the manufacturing processes. Okay, you are second year, they are final year. Okay, the production method, production method from input to output, from raw materials to final product, raw material to final product. Okay, different production method, because until and unless the manufacturing terms will not be clear to you, then it is difficult to think on industry 4. Okay, this is advanced version. Okay, okay, at least you got one idea what is industry 4. That is fourth industrial revolution. Okay, digitization, automation, all these things are here. Okay, okay, sure, sure. Thank you. It's my pleasure also. Okay, you have invited me. Okay, so I, you will call me for any requirement. Okay, as far as possible. Okay, I will try my level best because I am local only. My residence is here and my college is also here, NIT. So no problem. Even Saturday or Sunday, if required, I can come.